Okay, so today I'm going to talk you through the start of diagonal differences and then give you a little challenge to carry on with this. Okay, so diagonal differences, first you'll need 100 square. I just downloaded this one offline. And what we're going to do, we're going to start by drawing a 2 by 2 grid. Can you see I've drawn a 2 by 2 square over here on these numbers? And what I'm going to do, I'm going to multiply together the diagonal numbers. So I'm going to work out 33 times 44. And I'm going to work out 34 times 43. Just before we start, just quickly have a think. Which of those two sums do you think is going to give me the biggest answer? Okay, I'll just sit down to those two sums so you can see which of those two sums will give us the biggest answer. Now I'm going to work them out. I've started using the lattice method massively for my multiplying recently, so I'm going to show you using the lattice method. You feel free to use any multiplication method you want. 33 times 44. So put my diagonals on. So we've got 4 times 3 is 12. 4 times 3 is 12. 3 times 4 is 12. 3 times 4 is 12. That gives me 2, 5, 4, 1. So that's 1, 4, 5, 2. Okay, nice and easy. This one, again, draw a little grid out. 3 and 4, 4 and 3. We're going to do our multipliers here. So we've got 4 times 4 is 16. 4 times 3 is 12. 3 times 4 is 12. And 3 times 3 is 0, 9. Add them up to 15, 16. Carry the 1. 4, 5, and a 1. So that's 1, 5, 6, 2. That's 4. Sorry. 1, 4, 6, 2. No, even I make mistakes sometimes. So once I've got those two, I'm then going to work out the difference between the two answers. Difference means take away. So that gives me a difference of 10. Okay, nice and easy, 10. So what I'm going to ask, so we're going to work out, so today I'm going to talk you through the start of diagonal differences and then give you some extensions to try yourselves. So we start by getting 100 square. You can get one of these easily online. And I've just drawn a 4 by 4 grid around these a 2 by 2 grid around these numbers. Okay, and I'm going to multiply together the diagonals. So 33 and 44 and 34 and 43. So we've got 33 times 44 and 43 times 34. Okay, now before we start, just have a think. Which of those numbers is going to be bigger? Now we'll start and we'll see if you were right. So little grid. I'm going to use the lattice method because I've started using that recently. But you use whatever multiplying method you prefer. 33 times 44. That'll be 12, 12, 12, and 12. So that's 2, 5, 4, 1. So the answer to that one is 1,452. 43 times 34. Again, 2 by 2 grid. We have 43 times 34. Put my diagonals on. 3 times 3 is 9. 3 times 4 is 12. 4 times 3 is 12. 4 times 4 is 16. Let's add these up. So we get 2, 15, 16. That's 6 there, carry the 1. 4 and a 1. That's 1, 4, 6, 2. Okay. And then we're going to find the difference between those two answers. So difference means take away. 1462 take away 1452 gives you an answer of 10. Okay, so for this example, I got 10. Now what I want you to do is I want you to pause the video here and I want you to try at least 3 more 2 by 2 squares yourself. Okay, can you have a go at that now and pause the video? Okay, now you've had a go at that. What you're going to write is you're going to write a conjecture. Okay, now a conjecture, great maths word, means like a hypothesis. What do you think is going on? What pattern have you spotted? So I want you now to write down the pattern that you think you spotted. Now you've done that, we're now going to go into a stage where we prove it. Okay. Now, in maths, when we're asked to prove something, the only way we can do it to prove that it's always true is by turning it all into algebra. Okay, so I'm going to draw my grid out, my 4x4 grid. Okay, my 2x2 grid, sorry. And I want to imagine that this top square is called n. We don't know what the number is, it could be anywhere on the grid. I'm going to call it n. To get the next square, now if you look at my 100 grid, to get the next number, I've added 1. So this would be n add 1. Now I don't want to add any extra letters in, so to get these bottom ones, what I do is I look here and go, well, that's 33, that's 43. I've added 10, so that'd be n add 10. And then here, to get from there to there, I've added 11 on. That'd be n add 11. Okay. Then we're going to do our diagonal differences on multiplying across. So I'm going to do n times n add 11. And again, I draw like a grid for this. N times n add 11, which gives you n squared add 11n. Okay. I'm then going to multiply these two bits together. So I'm going to work out n add 1 times n add 10. Now, as with most proof questions at GCSE, they seem to want me to expand the bracket, which is fine because we can just use our grid method to help us do that. That's n squared, 10n, 1n, and 10. So overall, that gives us n squared add 11n add 10. I'm going to write this answer again underneath it. And what we do then is we take them away. So what happens is the n squareds vanish, the add 11n's vanish, and I'm just left with the answer 10. Now what that means is no matter what I start with, no matter where I start, no matter what that n is to start with, if I do this process, I always get the same answer. I always get the answer 10. There's no n in this now. So it doesn't matter what I started with, I only get the answer 10. So that's my proof of what my conjecture was. And I'm guessing your conjecture was I spotted that when I did a 2x2 square, I always got the answer 10. Okay. So now what you're going to do is you're going to extend this project into whatever you want. I'm going to give you a hint as a starting point. So what you might want to do now is you might want to change the size of your square that you start with. You might now want to choose a 3x3 square. If this is the case, you only look at the corners. You only look at the 4 corners, okay? And then you might choose a 4x4 square or a 5x5 square or a 6x6 square. And you might find with those answers, you can then come up with a general rule. So if anyone comes up to you and goes, right, I'm going to draw any size square on that 100 grid, what should my diagonal differences be? You can work it out very quickly. You might, after you've done that, then choose to change the shape. So you might choose to make a rectangle, a 2x3 rectangle, then maybe a 2x4 rectangle and a 2x5 rectangle. Okay. Again, each extension will give you another chance to find another generalized rule. So the whole aim at the end of it is someone's going to come up to you and go, I'm going to draw a square this size or a rectangle this size on that grid, and I'm going to work out the diagonal difference. Can you tell me what it is before I start? Okay, and this is what mathematicians do when we're working things out. All right, so remember each time 3 or 4 examples, then a conjecture, and then see if you can prove it doing some algebra. Excellent. Have fun. Bye.